Okay, these are called the sum and difference identities. So, yeah, I am recording. So, for the sine functions, we have a little cheer for you guys. Okay? You guys ready? It goes like this. Sine, cosine, cosine, sine, 3.14159.
Cosine, cosine, sine.
Signs are the same. So if it's plus here, it's plus here. If it's minus here, it's minus here. So you know the cheer, and then you have the same sign. All right? And then we've got the cosine ones. So here's my cosine ones. And this one goes cosine, cosine, sine, like that. Everyone ready? There's no reason, okay? So here we go. Cosine, cosine.
Sine.
It has to be quieter on the second one. Yeah. Just because. All right, you guys. Also, you want to memorize that the cosine ones go opposite. So this one's minus, and then it goes plus. So these are opposite signs. And for the tangents, I got nothing, so maybe you guys can come up with a super fun cheer for the tangent ones, because those are a lot less fun. 1 minus tan. That's good. All right, derive the difference formula for tangent. Okay, write small on this, and also you guys do have to derive these in the book, so you might be asked to do this on like a test or something. Derive the difference formula for tangent. So here's the difference formula for tangent right here. So I've got tangent of alpha minus beta, okay? And so tangent is sine over cosine. So we start by just writing tangent as sine over cosine, and it's of the same thing. So it's sine of alpha minus beta over cosine of alpha minus beta. Now we're going to do our identities for the difference of sine and the difference of cosine. So what's our cheer for sine? Cosine, cosine, sine. Yay. Okay, good. So we go sine alpha cosine beta minus cosine alpha sine beta. All right, so it always goes in order A, B, and the sine one was minus, so it stays minus in the formula. All over. Now we're going to do our cosine cheer. What's our cosine cheer? Cosine, cosines. That was really good. All right, so we've got cosine alpha, cosine beta. Always goes AB. And it was a minus, so this time it switches to a plus. And then it goes sine alpha, sine beta. All right, we are trying to actually get a tangent alpha right here. So in order to get a tangent, we need a sine over a cosine. So that means that we're going to divide every single term here by, let's think about it. First of all, I'm going to write exactly what I have here, but I'm going to leave space underneath, okay? So I rewrote the top, I've got my division sign, and I'm rewriting the bottom, but I'm leaving some space because I'm going to divide by the same thing to all four terms. So I'm going to divide here, I'm going to divide here, and I'm going to divide here, and I'm going to divide here. So I want to get a tangent alpha. That means I need to divide by a cosine alpha, and then I need this guy to just go away. So I have to divide by a cosine beta, okay? And then I do the same thing on all of these, right? So I can only do this if I actually multiply by the same thing or divide by the same thing. So cosine alpha, cosine beta, cosine alpha, cosine beta, cosine alpha, cosine beta. And this is going to turn into the tangent formula. So cosine betas cancel, and sine over cosine is tangent alpha. And then right here, my cosine alphas cancel, and sine over cosine is tangent, and this time beta. All over, this guy all cancels out to 1. Yay. Plus, what's sine alpha over cosine alpha? Tangent alpha. And what's sine beta over cosine beta? Tangent beta. And we get exactly this formula. That is deriving it. Isn't that fun? Yeah, you do. You do. I'm sorry. All right, let's simplify one. This one should take like 2 seconds because it's just got symbols. Cosine of the dollar sign plus the heart. That's so special. What is the cosine cheer? Are we ready? Okay, good. So this one goes cosine, dollar sign, cosine, heart. And then do we do opposite sign or same side? Sign. Opposite. Sine, dollar sign, sine. Yeah, that wasn't a very good heart. There you go. That's the answer, and you're done. All right, number 3. Simplify sine theta plus 45 degrees. All right, what's our cheer for sine? Sine, cosine, cosine, sine. 3.14159. That's so great. Okay. Sine theta cosine 45. Okay, same sign or opposite sign? Same. So sine, cosine, cosine, sine. Okay, so I just expanded it out. That's the formula. We can simplify slightly more because we know the cosine of 45 degrees. So what is the cosine of 45 degrees? Way to go, Harrison. Square root of 2 over 2. And samesies over here, the sine of 45 is also square root 2 over 2. So for this one, you could factor out that guy and write it like so. That's your final answer. All right, now for the tangent. So you guys, we don't have to derive it every time, thank goodness. We can just use the formula, which you might just want to memorize. So when you look at the formula, I have tangent x minus, we're going to change this to pi over 4. Everyone just do that now. Okay. So the formula says that it's going to be tangent x minus tangent pi over 4. All over 1 plus tangent x tangent pi over 4. And what is the tangent of pi over 4, you guys? Yeah, this tangent is when we divide square root of 2 over 2 by square root of 2 over 2, we get 1. So I can replace this whole thing with 1 and this whole thing with 1. So I get tangent x minus 1 over 1 plus tangent x times 1, which I don't really need to write since I'm multiplying it times tangent x. Okay? Okay, what if they give us one like evaluate cosine 15? Now we can use all our formulas to help us get 15. So we don't know 15 from the unit circle. We know 30s, 45s, 60s, 90s, know what I'm saying? So there's no way to add anything. We have to do a subtraction one on this one because like I can't add 10 and 5. That doesn't help us get anything that would be on the unit circle. So to get 15, anyone raise your hand, have an idea of how we could get 15 by subtracting 2 of our favorite ones that are on the unit circle, Maddie? We could do 60 minus 45. Evan, what else could we do? We could do 45 minus 30. Excellent. All right, you can choose. They're both equal to 15. I'm going to do the second one. Let's try it. So we're going to use our cosine formula, which is cosine, cosine, sine, sine, and we change signs. So it goes cosine 45, cosine 30, and then it's plus sine 45, sine 30. These simplify very nicely. So the cosine of 45 degrees, what is that? square root of 2 over 2. And then I have the cosine of 30 degrees, yep, which is the square root of 3 over 2. And then I have the sine of 45 degrees, which is square root of 2 over 2. And the sine of 30 degrees, which is 1/2. Multiply your fractions first, then get common denominators. So top to top, bottom to bottom, this is the square root of 6 over 4. This is the square root of 2 over 4. And our final answer would be to write this all over 4. That's as simplified as it gets, and you're good to go. All right, now I have sine of 195. Again, that's not on the unit circle, so I need to figure out two things, either adding or subtracting, to get 195. Okay, one thing that I would do if it ends in 5 is try to do 45. Okay, if it ends in 45, or if it ends in 5, do 45, because 30 and 60s, like, yeah. So if it ends in 5, then think about 45 and what number give you 195. That would be 150 and 45. So we just did a cosine one. Now we have a sine one. Sine, cosine, cosine, sine. All right, good. So now I'm going to expand this guy out. So I have sine 150 cosine 45. Is this one plus or minus? Okay. And then cosine 150 sine 45. And then we got to evaluate all of these. So 150 degrees is like here. So what's the sine of 150? 1/2. Okay, and the cosine of 45 degrees is square root 2 over 2. Then I have the cosine of 150, so that's the x part right here, which is negative root 3 over 2. That's the long leg. And then sine of 45 degrees is the square root of 2 over 2. Multiply straight across, that's square root of 2 over 4. And this would be negative root 6 over 4. And for your final answer, write it all over your common denominator. Okay, when you have radians, it's a little bit more annoying to figure out how it splits to a sum or a difference. Okay, so if you can't just see it, start with 2 pi over 12. Why would I start with 2 pi over 12? Because it's pi over 6, and that's the smallest one, pi over 6, and then pi over 4, and then pi over 3, right? So anyways, I'm going to try pi over 6. If I do 2 pi over 12, that makes the other guy 11 pi over 12. Is 11 pi over 12 on the unit circle? No, 11 pi over 6 is on the unit circle, but not 11 pi over 12. So that one doesn't work. So the next one that you would want to try is, if it's not pi over 6, I would try, okay, pi over 4, which would be 3 pi over 12 in this case, right? And that would force the other one to be 10 pi over 12, so that they would add to 13 pi over 12. So 3 pi over 12 reduces to pi over 4, and 10 pi over 12 reduces to 5 pi over 6. Are those on the unit circle? Yes. So I'm going to rewrite this as tangent 3 pi over 12 plus 10 pi over 12. And then I'm going to learn my tangent plus formula, which is tangent. Actually, let's go ahead and reduce this. I don't want to write all these as big guys, right? That's pi over 4. And then I'm adding tangent 5 pi over 6. I'm going to reduce that. All over 1 minus tangent pi over 4 times tangent 5 pi over 6. And we can simplify this one more. So tangent of 5 pi over 4, or tangent of pi over 4 Harrison, what is that equal to? It is equal to 1. Very good. And then we have the tangent of 5 pi over 6, which is here. Evan, what's that equal to? Good. Negative root 3 over 3. And then I have 1 minus. Tangent of pi over 4 is 1. And the same thing here, tangent of 5 pi over 6 is negative root 3 over 3. Now we have some fun with simplifying fractions. We need common denominators, so we're going to change this to 3 over 3. And I have 3 minus root 3 all over 3 then in the top. And I'm going to change this to 3 over 3. The 1 multiplies here, so this is just 3 plus root 3, because there's 2 negatives right there, all over 3. And then we flip and multiply, right? I'm going to take this denominator, and I'm going to flip it and multiply. And then this gets even more fun, because you can't have radicals in the bottom of a fraction. Tyler, are you sleeping on me? And so we have to multiply by the conjugate. Do you guys remember what the conjugate is? It's 3 minus the square root of 3. So it's opposite of what's in the denominator, 3 minus the square root of 3. These are great. So this would be 9. This would be minus 3 root 3 and minus 3 root 3, which is minus 6 root 3. And then I have negative root 3 times negative root 3, which is just plus 3. And in the denominator, we have 9. And the middle terms cancel out here, because I have a minus 3 root 3 and a plus 3 root 3, so those cancel. And then I multiply the last times the last, so that's minus 3. So now in the numerator, I have 12 minus 6 root 3 all over 6. And then this 6 divides into both of these, so it's 2 minus the square root of 3. You're welcome for that one.